Right, question 9. Same sort of thing again. Two different loci to draw. First of all, a modulus one, and then an argument one. So if I copy those over onto paper first of all then. So question 9A, and the loci that we're dealing with is Z, take 2, take 2i equals 2. Okay, let's get that into the standard form. Take the minus out, and we get 2 plus 2i equals 2. So, standard form, this is a circle, radius to center 2, 2. And then it asks us to sketch that. So again, it doesn't have to be perfect. Center 2, 2. Circle radius of 2. That's that. And then 9b, find given further that arc z take 2i equals pi over 6. Take the negative out. So standard result again, this time it's a half line from 2, 2, angle pi by 6, which I know is 30 degrees, from positive real axis. So just to sketch that on, it's going to start there and it's going to scoot off with that angle there being pi by 6. So this point here is what I'm interested in, where the two loci intersect. Now this time it's not so straightforward to get the equation, the Cartesian equation of the half line. Cartesian equation for this we can write straight down again. This is going to be x minus 2 squared plus y minus 2 squared equals 2 squared. So that comes straight out of your normal A-level maths work. But for this one now, what we need to do is replace the z with x plus iy, so that we've got the xy coordinate values in. So we get arg of x plus iy take 2, take 2i equals pi over 6. Now in order to get into that, we need to find the argument, which means we need the real parts and the imaginary parts grouped separately. So the real part will be x minus 2, the imaginary part will be y minus 2. And once we've got those separated, we know that the argument is the arctan of the imaginary over the real. So y minus 2 over x minus 2 is tan of pi by 6. Now, pi by 6 is 30 degrees. 30 degrees is one of the standard results, like sine of 30, sine of 60, and so on. Tan of pi by 6, or tan of 30 degrees, is 1 over root 3, or root 3 over 3. So I've got y minus 2 over x minus 2 is 1 over root 3. Now we need to substitute from either this into the one up there or vice versa. Now the shortcut to take here is to spot that in its entirety is y take 2. So if I rearrange this one and leave it as y take 2, I can substitute that completely into equation 1. Okay, so that's what we'll do now. We'll move my desk. Left-handed isn't great. So by substituting that into equation 1, I'm going to have x minus 2 squared plus, and then instead of y minus 2, I'm going to have x take 2 over root 3 all squared equals 4. Alright, let's simplify this a bit further. Don't expand yet. Doesn't matter if you do, but you'll see in a minute that there's another shortcut you can take here. Now you could expand that, cross multiply by 3 and so on, but if you think of this in terms of fractions, I've got one whole x minus 2 squared there, and I've got a third of an x minus 2 squared there. So I've got 4/3 x minus 2 squareds, or 1 1/3. And that saves you quite a lot of time dealing with expanding quadratics and then factorizing them again. Do your cross multiplying here, and you end up with x minus 2 squared equals 3. The 4's cancel, leaving you that. So x minus 2 is going to be plus or minus root 3. So x will be 2 plus or minus root 3. Now again, you can't ignore the plus or minus, but if we go back to the diagram, the Argand diagram there, we can quite clearly see that where that point P is, it has to be 2 plus root 3, because 2 minus root 3 would be this side. So we can say from Argand diagram, x must equal 2 plus root 3. What we've then got to do is substitute that now into our second equation that we generated in order to find the value of y. So sub in 2, and I get y minus 2 equals x minus 2, that's x, take 2 all over root 3. 2's cancel, so I get y minus 2 is root 3 over root 3, so y minus 2 is 1, so y equals 3. So therefore, at this point here, P, complex number will be x plus iy. Well, x is 2 plus root 3 plus iy 3i.